best thing I can do is not to learn how to program, but to learn how to use computers. And I would say that's the thing that this company has learned over the last 5 years, how to buy standard computers and standard programs and utilise them to the best effect for the manufacture and production of our products.
I believe that small businesses who do not invest in computers in the next 10 years are in fact going out of business. One needs a small computer to actually compete in today's world.
Designers aren't long-haired art students anymore. You know, we are sensible businessmen and we take our work very seriously.
LRAM Engineering employs about 50 people in its factory of 20,000 square feet. Although not a big company themselves, they design and manufacture products for some of the major companies in the country, such as the CEGB, water authorities and the mining industry. Water and sewage works use their actuators and power packs to operate valves and control the level of weirs.
We provide hydraulic muscle to do work that man couldn't do or wouldn't want to do. One problem we have, and it is or has been a major problem, is the amount of design and drawing that is involved in producing our products. We have around about to date 9,000 drawings up in the drawing office. Many of our products are standard products. Unfortunately, we never get a standard order. Usually, customers order a standard product, but they want a hand pump here, they want a shock valve there, they want some extra feature. So it entails taking a standard drawing and adding to it a non-standard product. Well, just imagine the difficulty searching through 8,000, first of all, entries in a book to find an appropriate one, and then going to one of about 50 drawers to find the drawing. And if it's possible to find it, then it's a question of rubbing out or scratching out ink, and OK, the drawing is modified eventually, but it doesn't look very professional. Now, around 5 years ago, computer-aided design became a viable proposition for the bigger companies. It would typically cost around £250,000, far too high a sum for small to medium companies. And around 2 years ago, personal computers became more of a proposition. And at the same time, several software systems came on the market for as little as, believe it or not, around £2,500.
With prices down to a more realistic level, the company decided to take advantage of a government scheme to advise them on the use of computer equipment. The consultant spent about a week in the factory assessing their techniques, and his findings led to the purchase of a personal computer and the implementation of computer-aided design, CAD.
Now, with electrical and hydraulic circuit drawings, 80 to 90% of a drawing is taken up on drawing symbols. Now, we have programmed into our system all the standard electrical symbols and all the standard hydraulic symbols that we use. And now, when we produce a drawing, it's simply a matter of pulling the symbols out of the memory, moving them about on the screen as we require them, connecting them together, and hey presto, a drawing is produced.
I call this drawing from memory. It's an hydraulic circuit I'm just about to modify it. First stage is to zoom in on the area I want to do first. Now in the space there I've got to insert a valve. And it asks for an insertion point, so I'll put it on the end point of that line there. Rotation angle 180. Unfortunately it's the wrong way around, so I have to mirror it on itself. Now that's done. Now I have to insert a pressure switch. I'll put that in the middle of those lines. Now there's just the text to add. Now type in pressure switch. I have to zoom back again to the original view and get it ready for printing.
It did take some time to program these symbols in. I guess it took a week to put the hydraulic symbols in and a week to put the electrical symbols in. It probably took 6 months to get fully used to the computer. So one has to be prepared to make these sacrifices. But once they've been made, I'm sure that the benefits far outweigh the initial disadvantages. It ensures that drawings are to the highest quality. The draftsmen were particularly sensitive about the introduction of CAD. They didn't really know what it entailed. They wondered whether it would be a threat to their jobs. And also they were nervous about assimilating the new technology. That's probably a pretty typical response. A certain amount of apprehension, but very quickly assimilating the system and then wondering how they ever went on in the old days of drawing boards. On the one hand, they like the traditional skills and maybe just feel a little bit nervous. On the other hand, possibly they wish they were working on the CAD because they feel as though perhaps they're missing out on future technology.
Whether they're a threat to his future or not, the computer takes away the laborious copying which is part of a draftsman's job. The bonus in this case is that the workshops no longer have to wait for drawings, and the customer, the employers and the employees are all active and satisfied. The system at LRAM is a very specialised one and obviously fairly expensive. However, there are many graphics packages which you can pick off the shelf at a very reasonable price. A designer needs a machine which should take away the tedium of straight copying, but it must not restrict his creative flair.
What we do is to help people market their products effectively. So it's taking the concept of a new product or an existing product which needs to be upgraded or relaunched in the marketplace. At Gus Honeyman Associates, what we try to do is to simplify this design marketing process. I am retained as a design consultant by companies like ICI and the Wellcome Foundation, quite major pharmaceutical companies. But also there's the guy around the corner, whose job is as important to me as the big ones. It's still a problem, a nut to be cracked, a problem to be solved. I'm just working on a product range at the moment, launching a range of trade decorative products and wallpaper paste and so on. And the budget is minimal, but it's that guy's livelihood, it's his house that's on the market to finance the project.
The ability to make rapid alterations to shapes or lettering styles on the screen is a great advantage.
It means that I can produce maybe 3 or 4 alternative layouts or approaches to a concept in a matter of minutes. One project we worked on recently was to design a symbol, a picture, a pictogram, which would be relevant to one particular area in Yorkshire, Halifax, Calderdale, and I'm sure they won't mind me mentioning them. They are undergoing a massive clean-up and regeneration programme in Halifax town centre as a whole, and I've been involved in designing a mark which goes on everything which is related to that particular programme, called that Inheritance Programme. That involved creating pictures and symbols which were particularly relevant to the Calder Valley. Here on screen we have an image of the final product, and what I'd like to do is just demonstrate very briefly the kind of facilities on-screen computing can offer in terms of editing a graphic image. For instance, if you can see the arrow here, or this little image here, we'll select an area of the screen. We can then blow it up into an enlarged pixel structure, and we can take an area which would represent that particular element, and we can then move that wherever we want. So if we feel that it looks better over there, fine, it's there. We've left a bit of a mark there, but that's no problem because we can retouch pixel for pixel so that we get an absolutely perfect curved line. We can check in this area here, which is a small window, what we're actually doing to the line. And you can see we've got a perfectly smooth line. We've moved it from there to there. If we're not happy with some of this detail here, we can use this exactly as we'd use a rubber, a pencil eraser. I mean, this is so simple. My 5-year-old daughter can use it. Physical time on the drawing board might take hours. And of course that saves the client money. And it makes me money, quite frankly. I mean, it's a nice compromise between a more economical job for the client and a more profitable job for me. And it means I can get through a lot more work in a working week. on an hour-by-hour basis. So it's. I mean, when I bought my computer, I was a little bit hesitant about how it was going to pay for itself, but it paid for itself well inside about 5 months, which surprised me. I thought it would take at least a year. And it's enabled me to take on an awful lot more work. The other big thing about it is it maintains confidentiality. A lot of the pharmaceutical work that I work on, I'm working on launching new and innovative products. It calls for maximum confidentiality. I mean, I cannot, and my clients cannot afford pre-launch information being released on the marketplace. So the computer works very well in that, because we can cut down the amount of people involved in a project. And another big and very, very sensible plus for a computer is the fact that, in one little 3.5-inch disc, I can keep as many images and drawings on that disc as would fill a rather large plans chest. So in terms of space, it helps enormously. The problem has always been with computers is what we call hard copy. What we have now is a conventional dot matrix output. This will now have to go to an artwork studio so that it can be drawn up into finished artwork quality for print reproduction. We're now looking at future technology which will enable me, as a designer, to hand this disc, which contains the data file, over to a printer who will be able to put it into his computer and transfer that image directly onto film or photographic paper, which is then processed and becomes the final finished artwork. This is quite a leap forward, because it means that the studio process is cut out, or at least cut down to a minimum. It's saving money all the way around, and it's using microcomputing to its ultimate effect. Having spent all my money on a computer, I thought, well, let's make it pay for itself. It's got to do everything. And I was using it in a very silly fashion. Everything went through the computer. But there are certain things which, computers are tools, and I think certain things which they're not very good at doing. I mean, they need people as much as people need them, really. I mean, a computer will never actually design anything for you. It's a tool.
No one will argue with the fact that computers need people, but increasingly they're needing less people as routine tasks no longer need the human touch. With me is Barry Sherman, who's an author and freelance consultant on the impact of technology in our lives. Barry, very briefly, are computers causing unemployment?
Oh, I think there's no doubt that they are. Only it's not quite as simple as it sounds. It's not always just you put a computer in and in that particular company a job goes. For example, if you take that designer just now, that particular designer wasn't sending as much stuff to an artwork studio. Well, he may be keeping the same number of people. He may even take on a few more people. But what's happened in the artwork studio? They haven't got as much work. The odds are they're laying off people. So you can lose jobs directly and you can lose jobs indirectly. But I think you've actually then got to really fine things down even more. If you're a big company, there's almost only one way that jobs are going to go, and that is down. Because big companies are going to introduce new technologies, going to introduce computers, design computers, computers for actually production line computers, computers in clerical areas. They are all going to be there to cut costs, to increase productivity, to make themselves more efficient and to compete. And when they do that, they're going to use fewer people, so employment will go down. But if you're a small business, the odds are you actually want to expand. Most big businesses have got to a point where the expansions that they make are by acquisitions of other companies. Small businesses expand, period. So they will almost certainly, even though they're using computers, they will actually take people on. I mean, that's a bit of a kind of sweeping statement, but more people will probably, in small businesses, take on people. They will take on more and more workers than certainly any large business will ever do. So from the point of view of just employment, it's very nice to see small businesses doing well. And I agree with the man who said that you will not, in fact, right at the beginning, who said you will not find many small businesses without forms of computers. They really must use them to survive. And really, you've not seen anything yet anyway. Because frankly, we're only at the beginning of using computers. If we look at the moment at all the people who are working in clerical areas in Great Britain, in administrative areas, if we look at places like the Prudential Insurance Company, great big building in London, if we look at the big government departments, big local authority departments, they're full of clerical staff whose main job is to take information amend the information, and then send the information on to someone else. Now, very shortly, all that will easily be done by computers. The price of the computer is dropping. The price, and very importantly, the price of the link between computers is dropping, the telecommunications link. And when that happens, you're going to find a terrific loss of jobs in clerical areas as well as the manufacturing areas we see now. Now, this has one very, very important point, and that is that the manufacturing areas that have lost the jobs are in the north of England, but the clerical jobs, the really big centre of clerical administrative jobs, is London. And it is likely that in the early 90s, mid-90s, London starts to go the same way in terms of jobs as has the north of England and the Midlands of England. And I don't want you to think that, and it isn't true, that you suddenly find masses of people made redundant. What actually happens is that a company will find that it can now do either the same amount of work or more work using the same number of people and then fewer people. So they just let people go and they don't replace them, natural wastage. They encourage people to go, voluntary early retirement. They don't take on juniors. They don't take on young people. They may take on YTS kids, but then they don't employ them afterwards. And at the end of the day, it's young people who aren't getting the jobs. And one of the problems with this computer revolution is that, in fact, young people are the ones who understand the computers, but they're really the people who aren't getting the jobs in the company that are using them.
So, should we welcome the new technology if it is going to cause this unemployment?
I think actually we have to, because quite frankly, you've got two choices. You either use the technology and compete and create unemployment, or you don't use it and you don't compete and you create unemployment. The problem the second way, not using it, is that in fact then you don't have any profits, you don't have any income, you don't have the wherewithal to do something about the unemployment. If at least you're using it and you're a high value-added, high productivity society, you're competing in the world, at least there should be the money to be able to do things for the unemployed. Maybe in fact start reducing working time. Maybe start, within the confines of being able to compete, start sharing work around. Why not really work 6 months in a year in the future? Why work kind of 10 months, 11 months every single year? There's nothing really marvellous about working. A lot of people don't like it at all, you know, not when they get to work.
So you see that's the way that we will go, that we'll work less hours or we'll start to job share?
I think it's actually inevitable that computers will lead to some form of job sharing. You see, one of the things computers can do, which is actually a marvellous thing, it can release resources. It can release people to do other things. And there's so many things in Britain that need doing. So rather than look at them as really a problem in creating unemployment, I think if we had politicians and a government and perhaps ourselves, industrialists, trade unions, who actually looked at the whole impact of computers, saying, look, it's not a problem, it's a challenge. We've got all the things just there where things need to be done, demands and needs which aren't being met. We've got people there which the computer is releasing. It's doing all the routine stuff for us. It's releasing. They can do those jobs. And the trick of any government, of any society, is to match up those people there with those unmet needs and demands just there. Of course, the computer could enable us to do it, though I must admit that right now it doesn't appear to be doing it.
So things may be brighter in the future?
Well, there's absolutely no reason, if we come to terms with the computer, we come to terms with what is a new industrial revolution. There is no reason why it should not be an incredibly better life, as indeed was the first industrial revolution.
Well, that's a nice, bright note to finish on. Thank you very much, Barry. We've already seen a couple of instances where the computer can help in the commercial aspects of design, but can it also help the consumer directly? At Kitchens International, it does. Kitchen design consultants spend a lot of time creating layouts and working out costings for potential customers.
Good afternoon. Are you looking for furniture or appliances?
Both, really.
Well, we've got quite a number through the building. Is it gas or electric?
David Wilde felt that his time would be better spent with his clients, assessing their needs more accurately. He thought a computer could help by doing the routine work.
Look at this new AEG built under oven. We bought the equipment, we immediately ran the software that was supposedly for kitchen design, and unfortunately it wasn't up to scratch and didn't work. So at that stage we had to sit down and say, look, we need a system to do this, and we did the specifications and we've built up over 2.5 years a system that actually works. The menu that comes into view gives us the information regarding the customer's name, sizes of the room and number of doors and windows, along with the wall that we're working on, which is wall number 2, and the free length available on that wall for actually inputting units. If we then go look at the bottom of the screen, we can see that it's asking for a unit code. By typing in a code, not forgetting whether it's a right-hand or left-hand unit, it will check on the file and bring up the description of that item. And the unit is immediately drawn up on the graphics screen.
Continuing in this way, all the units are added until the layout for the entire kitchen is produced. At a keystroke, the design can be redrawn in elevation. While the plans and elevations are being created, the computer is memorising the manufacturer's code for each item and will be able to produce an accurate costing along with an order form. At any stage, prints can be made on a dot matrix printer. Details of PowerPoints, hob units and other fittings can also be included.
We can produce a 3D view from anywhere within the kitchen. We use the plotter to give us a finer drawing. Obviously, what we've done today has been a very simple drawing. But we could view just part of a kitchen that in fact could fit into someone's home. As indeed this one does.
Right, Alan, I'll get this one, you'll get... Yes, just a bit. Right, I'm ready for a cup of tea, though. It's always nice.
As well as producing the drawings, there is a variety of printouts that can be automatically produced. The first one is for the customer and costing, which shows the individual prices. It's then ordered, and here the codes are altered to be those codes required by the manufacturer. And finally, a schedule of all items for the fitters and for the customer to know what she's getting for her money. The staff have welcomed the implementation of a computer system. Before, each individual used to run their section, and as such meant that a lot of the work that they did was quite monotonous and quite repetitious. Whereas now, using the computer has opened up a lot more possibilities. It makes the job a lot more satisfying because she's not doing purely and simply copy typing. Once we had familiarised ourselves with the kitchen design programme, we started to look at the other ways that the computer could in fact help us with the business. And the main areas seemed to be in the financial side. We found not only did we do the sales and purchase ledger, we do our incomplete records, we do our financial analysis and stock controls, all on the computer. And it's run by, once again, a variety of the staff. So it's no longer a case of there is only one person can do one job. If someone's off sick, there's no problems in actually getting the continuation. This leaves us free to be able to spend more time with the client, finding out really what the client needs, so that we can make sure at the end of the day they've got a super kitchen. Married on the wall cabinet there, which opens up to a nice open display shelf.
Until now, we've only seen people talk to computers. What about computers talking to each other? Next week, Dr. Paul Johnson is using this digital dialogue in his medical research into the causes of cot deaths.